Hello and welcome to the demo presentation of the first challenge from the GIBDET Colombia chapter of Omdena. The name of the first challenge is Mapping of Agroforestry Systems based on Artificial Intelligence. The problem is that agroforestry systems are widely known for their contribution to the generation of environmental goods and services. In this way, we aim to create a tool to identify this class of systems, simplify the information within the images, and produce a map of the segmentation of agroforestry systems. The objective was to develop a model to identify agroforestry systems and help map areas where they have been established. For this, we used orthophoto mosaics, which are similar to aerial or satellite images with very high spatial resolution. With this idea in mind, several models were developed to identify agroforestry systems within remote sensing images. The project took 8 weeks. How did we do it? First, we conducted research. We researched books, articles, newspapers, and various other sources to get a clear idea of what an agroforestry system looks like in the real world, its rules and patterns. Next, we performed an exploratory analysis and data cleaning. We searched for orthophoto mosaics containing examples of agroforestry systems to create our own data set of system images. We then trained machine learning models using TensorFlow to identify agroforestry systems in the orthophoto mosaics. Finally, we tried to create a container using the IDB, Inter-American Development Bank repository, to put everything together. Here's an example of what an agroforestry system looks like. It's a combination of crops and trees arranged in characteristic patterns. Agroforestry systems have complex features, but with sufficient training, the models can recognize them. Our work involved creating a dataset using polygons. The main idea was to draw polygons on orthophoto mosaics to delimit agroforestry systems and make cutouts. We had two features: the image of the agroforestry system and the corresponding mask or polygon. We used several orthophoto mosaics like the one shown in the image. All of them were extracted from the EAC repository called Colombia and Maps, which was the primary database for this project. After obtaining the images and polygons, we created a dataset containing both the image and the mask polygon. We tried to predict the mask using TensorFlow models and implemented several models like XGBoost. Also, we have used UNet model. As you can see, we have the training level, the prediction level, and the model metrics. We also used the container and the code from the BID repository to process the information and created a segmentation classification map. On the left side, we have an image with high resolution and a lot of information. On the right, we have a segmentation map that only contains the features we're interested in. This map shows areas of concentration with yellow or green pixels indicating a high probability of being part of an agroforestry system. Blue pixels have a low probability of being part of the system. This classification map focuses solely on agroforestry systems. What have we learned from this project? Well, we need a better data set with more images and examples of agroforestry systems to achieve better results. Implementing a container is crucial for sharing and using the model developed during the project. The process of labeling consumed the most of the project's time, and the quality of this data influenced the subsequent steps. Lastly, the diversity of skills, ideas, and ambitions positively impacted the project outcomes. Finally, I want to say thank you very much to all the collaborators involved in the project. We appreciate your time, and if you'd like to learn more about the details, steps, and processes undertaken during the project, you can watch the full video on the GIBDET Colombia chapter Omdena webpage, where we explain everything in more detail. Thank you once again, and we hope to see you next time.